Yeah, we're going to continue recording. I'll have to wipe out some old stuff on the hard drive. All right, sorry, give me just 1 second. Because I'm saving these recordings locally, I need to make sure I have enough hard drive space. Kill anything from earlier than, let's do like that. Shift delete. Oh yeah, this can go too. Shift delete. It's shift delete. This shift delete. All right. So we have a few things to talk about today before we get into the new material. The first thing I want to talk about is exam 3, which took place, of course, last Friday. One, I'm like so proud of you guys. You did, for some reason, so much better than my other section when it came to just getting HonorLock to work, like just following the directions. A lot of people, though, did have various forms of trouble. I did my best to sit there and answer questions as they came in. Nevertheless, there were still some people who weren't able to get in for various technical reasons. Most of those were like direction things from what I've been told. So HonorLock says if you had that problem where after you did your room scan, showed your ID, gave them the token, HonorLock didn't automatically enter the password for you, that is apparently an indicator that something in the previous steps went wrong, like the ID verification or the room scan or something like that went wrong, and that's why they didn't enter them. When I called HonorLock support after getting the first email that said that, they told me to point everybody to the live chat on the website so that the folks through the chat could kind of walk you gently back through that verification process. Did anybody have an experience like that that didn't work out, or have something that is contrary to what the HonorLock support people told me? Was anybody able to get a hold of someone on live chat but still not able to get into HonorLock to take the test? You're still not able to get the password to autocomplete to get the MyMathLab test open? Remember, you can hold your spacebar to unmute your mic and talk. Or type in chat. Okay. Yeah, so what I've done is I sent out an email. I'm going to go ahead and switch over to the .cam now. If you weren't able to complete exam 3 last Friday, please reply to the email I sent to your sfcollege.edu email addresses about the makeup. The makeup is going to be run the same way. It's going to be run in MyMathLab using HonorLock. We have to get this working. Because this is how the department is having us do the final exam for college algebra. All MAC1105 classes, got to do it this way. That means I really want us to resolve all of those problems before the day of the final. I requested the HonorLock tokens for the makeup over the weekend, and I got an email at 5:30 this morning giving them to me. So the makeup is not going to be today. I didn't get that information in time to start sending it out. So the makeup test for exam 3, which is only for folks who had tech issues. Who couldn't get in last Friday. will be Wednesday. During class time. It will run exactly the same using HonorLock and my math lab. So we need to fix whatever those issues were. Whatever it is that kept you from being able to get in on Friday, if we don't fix it, we'll keep you from being able to get into the makeup exam. So it's something we need to resolve, whatever that problem was. The final exam will be run the same way. It'll also use HonorLock, and it will also be on MML. For your class, and I'll double check this, I think it's the 28th at, not this, it's the 28th, this is my other section, at 10:30, I believe, but let me double check just to make sure. So you guys are here, here, here. Yeah, right there. So final exam, 4/28, a week from tomorrow at 10:30 a.m. Now, there's also exam 4. It's going to be a take-home exam. It's going to cover chapter 6, which is the stuff that we're going to talk about this week. It's a short chapter. It's an easy test. But you're going to have to write your solutions on paper, scan them, and submit them to Canvas. Both classes seem to have trouble with the scanning and submitting to Canvas stuff. So I'll remind you, you need to download an app like Cam Scanner or TinyScan. There's a bunch of them. Just search Scanner app in your phone's app store and find one that is free and highly rated. There's lots of them. Cam Scanner is my favorite, and there is a free version of Cam Scanner. Works great, works awesome, love it. The reason for that is if you submit these in PDFs, as PDFs in Canvas, Canvas will organize them all by your last name and by section. It will allow me to annotate where I can write in comments and mark them up, which just does not work as well with JPEGs or HIC files or any of those other things. If you email me a picture, then I would have to convert it to a PDF, scan it, and upload it to Canvas. And I just don't have time. I have way too many students. So I need you guys to carry the ball on this a little bit. It's not that hard. It will take just a few minutes. If you haven't done that yet, please go ahead and do it. It'll still let you submit the assignment. It'll show up that it's late, but that's okay. There's not going to be any problems from that. So if you haven't done that yet, please scan your scratch work using something like Cam Scanner from Exam 3 and upload it to Canvas under the assignment titled Exam 3. But Exam 4 is going to run the same way. So it's going to be a take-home, and you're going to submit your work in the same way as you did your scratch work for Exam 3. So I'm going to send out a PDF. You will write solutions to those questions on your own paper, and then you will scan those solutions and upload them to Canvas under the assignment titled Exam 4. So you will receive the test this Friday, and work it between that day, Friday, and the day of the final. To hand it in, you must scan your solutions Again, I recommend Cam Scanner. Or you could also use something like TinyScan, DocuScan. There's a bunch of them. And submit those on Canvas. So any questions about testing stuff? If you weren't able to do test 3, the makeup will be on Wednesday. It's going to go the exact same way as the test on Friday did. So if you had tech problems, we need to get them fixed. I don't know how many questions will be on the final. The committee is still working on it. The last version of the final that I saw had about 20 questions, but I understand that they are attempting to add some more. Exam 4 is going to be just like one of our normal tests, so it will have around 15 questions, and it will be covering systems. Exam 3 ended up having, I think, 16 questions altogether, the original version, and the makeup version that you'll take on Wednesday if you weren't able to get in will also be around that length, because most of them are multiple choice. They go very, very fast. And I think the average time spent working on Exam 3 was around 20 minutes, so nowhere near the whole hour was necessary. But yeah, the final exam, I'm not sure. The date of the final is 4/28, and it's at 10:30 a.m. Exam 4 is a take-home, so I'm going to give it to you this Friday, and you will hand it in no later than the day of the final. All right, so this is due on 4/28. Any other questions regarding testing? All right. So the new material, this is the last bit of material that you need for college algebra, is on systems. So this week, there will be new homework and new quiz. It's all from chapter 6. It's on systems of equations and inequalities. So today we're going to start talking about systems of equations. And as the week progresses, we will talk a little bit more about equations and then about inequalities as well. As with all things in math, there's only one place to start, and that's with a definition. A system of equations is a collection of equations meant to be solved simultaneously. So what I mean by that is you're going to find some numbers to plug in for the variables that don't just make the first equation true, but make all the equations true at once. So for our first little example, I'll give you a system. How about x minus y equals 2 and x plus y equals 0. And let's see if some numbers are or are not solutions to this system. So check if this system is solved by, first let's check the ordered pair 0, 0. Actually, let's check the ordered pair 3, 1 first. and then we'll check the pair 0, 0, and then we'll check the pair. How about, what do we need here? Negative 1? All right. So solutions to systems are ordered tuples. Like each of these is an ordered pair. Each of these is an x value and a y value. In other words, for a system where you have two equations and two variables, the solutions look like points, right? Look like points in the plane. If I plug in 3 for x and 1 for y, is this first equation true? Let's see, so x minus y, that would be 3 minus 1 equals 2. Is that true? Yeah, it is. So far it looks like 3, 1 might be a solution to this system, because when I plug 3 for x and 1 for y, this first equation is true. But if I plug 3 for x and 1 for y into the second equation, I get 3 plus 1 equals 0. That's not satisfied. So this point 3, 1 is not a solution to that system, because a solution to that system has to solve both of these equations at the same time. And when x is 3 and y is 1, even though the first equation is satisfied, the second one is not. And we can look at 0, 0. So let me recap here. So 3, 1 is not a solution to the system. All right, that's what we learned in that first bit. If I plug 0, 0 into the first equation, I get 0 minus 0 equals 2. This is not satisfied. So I could actually stop here, because I know a solution to the system has to satisfy both equations, and the first equation is not satisfied. Right? We can check the second equation. 0 plus 0 does equal 0. This one is satisfied. But by the same logic we applied to the previous point here, since only one of the equations is true when x and y are both 0, this point is not a solution to the system. Are we both clear on why neither of those points are solutions to the system of equations? Questions about that? Okay, let's take a look at this third point. If I take the point 1, 1 and I plug it into that first equation, I get 1 minus -1 equals 2. Is that true? Well, 1 minus -1 is the same as 1 plus 1. So yeah, this is true. And the second equation, x plus y equals 0. Well, that would say 1 plus -1 equals 0. But 1 plus -1 is the same as 1 minus 1. So yeah, this is also satisfied. Therefore, the point 1, -1 is a solution to the system. Why? Because both equations are true when x equals 1 and y equals -1. So we found some numbers we could plug in for the variables that make both equations true at the same time. And that's precisely what it means for those numbers to solve the system. There are a whole bunch of fun questions you can ask about systems of equations. Like, okay, so here, this is a solution. How did we find it? Right? I gave you these 3 points and asked you to check if they were solutions, but how on earth did I come up with this point? How did I know that that point would solve this system? Another reasonable question to ask is, are there any other solutions to this system? Right? Does this system have one solution, or does it have two, or does it have three, or does it have a million? How many solutions to the system could there be? Both of those questions are interesting to answer, and we're going to look a little bit more deeply at both of those questions. And in particular, today I'm going to show you how to find this point, 2 different ways. The second question is actually the deeper one in some senses. How many solutions are there to a system? And it turns out to answer that well, we can think about the geometry of the system. So I'm going to give you a geometric way of interpreting these things. But before we do that, I want to talk about different types of systems of equations. So classifying systems of equations. Basically, there's two main categories. Linear and nonlinear. Now, saying I can categorize systems of equations into these 2 boxes is like kind of like saying I can take all the objects in the world and organize them as to whether they are bananas or whether they are not bananas, right? I mean, there's a bunch of things that are not bananas. It's kind of a silly way to do it, like is linear or is not linear. But linear systems, there's a reason we do it this way. Linear systems are very well understood. We know, and when I say we, I mean like the mathematical community knows everything there is to know about linear systems. It also turns out to lead to a very important branch of mathematics called linear algebra. Linear algebra is the mathematics that underpins really fucking everything, like calculus in higher dimensions, planetary motion, even general relativity and quantum physics. It's all about linear algebra. Linear algebra is kind of the backbone of basically all modern mathematics. So linear systems are systems that we like a lot, and I'm going to show you some general methods for solving linear systems. We're going to talk about how many solutions a linear system can have, all that good stuff. We will come to understand them very well. Nonlinear systems, this shit's rough. There's no good general theory. If you just hand me a random nonlinear system, it's very hard for me to even tell you whether there will or will not be a solution, let alone how many solutions they are, and I'm even further from knowing for sure how to find those solutions. So we like linear systems a lot. Linear systems are awesome, beautiful, wonderful things. Nonlinear systems, they can be cool, but they're considerably harder to work with, and the theory that you develop as you start to study them is not as nice as the theory behind linear systems. So we will primarily focus on linear systems. So let's solve a linear system. Oh, hang on. What makes a linear system linear and a nonlinear system nonlinear? So a system of equations is linear if every equation in the system is a linear equation. All right, that's it. So remember what a linear equation is. It's an equation where the variables only ever show up to the power of 1. Right? No higher powers, no weird powers, no variables downstairs, no variables under roots. So for example, like 2x minus 3y plus 1.25z equals 12. This is a linear equation. Whereas 2 times the square root of x plus 3y to the 4 minus 1.25 over z equals 12 is very much nonlinear. Right, so if your equation has variables under square roots, variables raised to power different than 1, or variables downstairs in fractions, those are nonlinear equations. But if your equation only has variables showing up to the power of 1, multiplied by constants, added up, no variables under roots, no variables downstairs, then that is a linear equation. There's two methods for solving linear systems. There's only one method for solving nonlinear systems, and it doesn't always work. So the two methods for solving a linear system are called substitution and elimination. And I think probably everybody has seen substitution before, but maybe not everybody has seen elimination before. So let's go through this. I'll solve one with substitution. Let's solve 2x plus y equals 0. And negative x plus 4y equals 1. Let's solve a system by substitution. So solving by substitution means you're going to solve one of these equations for one of the variables. Like maybe here I'll solve the first equation for the variable y. Then you're going to take what you get from that and plug it into the other equation. So if I first solve the first equation for y, and you could solve it for x instead, it doesn't matter, you just pick a variable in one of the equations and solve. We get y equals negative 2x. Then I substitute that value, or that expression, in for y in the second equation. So here, what would that look like? Well, I've got negative x plus 4y equals 1. So that would become negative x plus 4 times negative 2x, because y is negative 2x, equals 1. Is this clear? So I solved the first equation for y, and then I take that and I plug it into my second equation. So everywhere there is a y in my second equation, just right here, I write negative 2x instead. So negative x plus 4y equals 1 becomes negative x plus 4 times negative 2x equals 1. Now this is an equation which only has one variable in it, so I can solve it explicitly. Four times negative 2x is negative 8x. So this is negative x minus 8x equals 1. which is the same as, well, negative x minus 8x, that's negative 9x equals 1, which is the same as x equals negative 1 over 9. But remember, the solution to a system isn't a number, it's a pair of numbers, because I've got two variables here, so I need an ordered pair. So finally, to find y, I back substitute x equals negative 1/9 into either equation. So here I'll take x equals negative 1/9 and plug it into this first equation. Let's see, I would love to, here, we'll do it like this. So I'll take my x equals negative 1/9, and I back substitute that value into either of the original equations. And in this case, I'm going to put it into the first equation. So I'll have 2 times negative 1/9 plus y equals 0. All right, that's what I get when I back substitute negative 1/9 for x into this first equation. Into this first equation, 2x plus y equals 0. If x is negative 1/9, then 2x plus y equals 0 is 2 times negative 1/9 plus y equals 0. Now I can solve this for y. 2 times negative 1/9, that's negative 2/9 plus y equals 0. And then I can just add 2/9 to both sides, and I get y equals 0 plus 2 over 9 is 2 over 9. So finally, solution to the system is negative 1/9, the x value, comma, positive 2/9, the y value. And that's what we were looking for. This is the whole procedure, right? So starting. So I think most people have seen substitution. I think usually you learn substitution at some point in high school. It's actually not that good of a method. As the systems get larger, if I had 3 equations and 3 variables, substitution becomes a pain in the ass. If I had 5 equations and 5 variables, substitution becomes really unpleasant. It takes a long time. The other method for solving systems is what's called elimination. And that is the last thing that I'm going to require you to learn in this class, is how to solve a system of equations, specifically a system of linear equations, using the method of elimination. So I want to go through and solve this same system by elimination next. But before that, I want to show you the geometric interpretation here. So let's get rid of all these. I'm going to use Desmos to graph both of those equations. 2x plus y, y equals 0, and negative x plus 4y equals 1. So both of those are lines. And if you look right here, this point is the solution. Negative 1 over 9, comma, 2 over 9. All right, you see that green point showing up there? That's my solution. And its x-coordinate is negative 1/9, its y-coordinate is positive 2/9. So the solution to a system of equations is the point where the graphs touch each other. For a linear system, where the equations are both having graphs that are just straight lines, there could only ever be one solution, right? Those lines could never touch each other in more than one place because they can't curve around. It's also possible that they don't touch each other at all, that they're parallel. And finally, it's possible that they sit right on top of each other, that they touch each other everywhere. And those three cases correspond to the three situations where you could have either one solution, no solutions, or infinitely many solutions. But we'll talk more about that on Wednesday. For now, what I want to do is show you the method of elimination. So let's return to this. I'm going to solve that same system. (2x plus y equals 0 and negative x plus 4y equals 1 by elimination. So the elimination method is the method that generalizes to higher dimensions better. If we had more equations and more variables, elimination would be the way to go. And so it's one of these things that that is very much worth learning, right? It's like learning how to factor a quadratic instead of always plugging into the quadratic formula. It works every bit as well. It provides solutions, but it also gives you some deeper insight and is a method that generalizes to solving more equations. Like the quadratic formula only works for quadratics, but if you learn how to factor, all of a sudden you can solve cubics and quartics and quintics if you're good. So elimination is the method that generalizes in that same fashion. And here's the nuts and bolts. You're going to multiply through one of these equations by a constant such that if you were to then add the two equations, a variable would go away. So you want to multiply through one of the equations by a constant, and that constant is chosen such that if we then add the equations, one of the variables goes away. So for example, if I multiply through equation 2 here, the second equation, by the number 2, then this would become negative 2x plus 8y equals 2. And if I were to then add the two equations, I would have 2x plus negative 2x, which would be 0x. So the x's would go away. Or if I multiplied through equation 1 by negative 4, this would become 8x minus 4y equals 0. And if you were to add the minus 4y to the plus 4y here, the y's would go away. So I'm going to eliminate y. I'm going to do what I just described. To do this, I multiply through the first equation by negative 4. So I rewrite this whole system. The second equation doesn't change, but the first equation, if I multiply 2x by negative 4, I get negative 8x. Y times negative 4 is minus 4y, and 0 times negative 4 is still 0. So that's what the first equation becomes. Second equation, I just leave him alone. So notice that after I multiply through that first equation by negative 4, it's the case that if I add this to this, the y's all go away. So now I add the two equations together. Negative 8x plus negative x is negative 9x. Negative 4y plus positive 4y is plus 0y. And 0 plus 1 is 1. Everybody see this? So this is how elimination works. Now I have the equation negative 9x equals 1, because 0 times y is 0. And I can solve that by dividing both sides by negative 9. I get x equals negative 1/9 right away. And then I can back sub into either original equation just like we did before. So I'll have 2 times negative 1/9 plus y equals 0, which is the same as saying negative 2/9 plus y equals 0, which tells me y is 2/9. And so the solution is negative 1/9, comma 2/9. So this is the superior method for a bunch of reasons. First, it's fast. It's faster than substitution. Second, it works on more shit. It works on larger systems. Third, it's more efficient, and it leads to the discovery of linear algebra. This leads eventually, in ways that might not be obvious from what we're looking at now, this leads to the study of matrices and higher dimensions. This leads to all sorts of really beautiful things. So elimination is the last skill I require you to learn in college algebra. It's not just me, it's the last skill that you are required to learn, period, in college algebra. And you have to learn it. There will be questions on that take-home that require you to solve a system by elimination. If you give me a solution that involves substitution or something else, then I won't be able to give you credit for that. So you must learn how to solve systems using elimination. It is the better method. I understand that there's usually a lot of friction, right? When you have a tool that works and somebody says, well, here's another tool, you have to learn to use this new tool, we like to just stick with what we know. And if you know substitution and you're comfy with substitution, I understand being reluctant to learn elimination. But trust me, please, that elimination is the superior method. It's the method that will serve you better as you move forward in your mathematical careers. Even if you're not going to be a mathematician, there will be math in your lives in the future. It will probably be linear algebra because it's the most prevalent form of mathematics anywhere. And it will require the use of this elimination method, which is sometimes also called the Gauss-Jordan method or Gaussian elimination. But yeah, questions on this example. How we solved this system by elimination. If we have time, it looks like we do. The last thing I'd like to do is look at a nonlinear system with you. Nonlinear systems are nowhere near as nice. Let's look at x squared plus y squared equals 8 and x minus y equals 0. The system is nonlinear because the first equation is nonlinear. The equation x squared plus y squared equals 8 is nonlinear. It's a circle whose radius is 2 times the square root of 2 and whose center is the origin. We can take a look at a graph. So here's that first equation, x squared plus y squared equals 8. It's a circle centered at the origin. Its radius is the square root of 8. I can graph the second equation also, x minus y equals 0. Looks like this. So from the graph, it looks like there are two solutions. There's one right here, and there's one right here. And Desmos is able to tell me that those solutions have these coordinates. But if I couldn't read that from the graph, or if these numbers were not so nice, we would need to solve the system by using substitution. So here I will use substitution. The second equation is the same as x equals y. Right, just add y to both sides. So I can sub this into the first equation. Since x is equal to y, everywhere there's an x, I'll put a y instead, so I get y squared plus y squared equals 8. So the second equation, x minus y equals 0, is the same as saying x equals y. So I take x equals y, and I substitute that into this first equation. So everywhere there's an x, I write y instead. So x squared plus y squared equals 8 becomes y squared plus y squared equals 8. Y squared plus y squared, though, that's 2y squared. So this is the same as 2y squared equals 8. And then I can divide both sides by 2. And I get y squared equals 4. This gives the two values, the two y values, y equals 2 and y equals negative 2. Right, because the two y values plus and minus 2. Now if y is equal to 2, I can back sub into the second equation. X minus y equals 0 becomes x minus 2 equals 0, which means x is also equal to 2. And I can back sub this into the second equation. X minus y equals 0 means x minus negative 2 equals 0, means x plus 2 equals 0, so x is also negative 2. So I get the two solutions, 2 comma 2 and negative 2 comma negative 2. And those are the two solutions that we saw when we graphed these in Desmos. This is a very nice nonlinear system, right? I chose the numbers in the equations here to make the solutions exist. One, no guarantee that the solution would exist. And also be clean, right? Have integer coordinates. But in general, the solutions to nonlinear systems can be quite horrendous. It can be hard to even tell when they exist. And when they exist, it can be hard to find them. There is no method that always works for a nonlinear system. Elimination always works for a linear system, right? If a solution to a linear system exists, elimination will always find it. Neither elimination nor substitution always work for nonlinear systems. So there are lots of nonlinear systems that we just straight up don't know how to solve. And I don't mean like you and me, I mean like the broader mathematical community cannot solve them. So we're going to study linear systems a little bit more. We're going to get a bit more practice with elimination. And then we're going to talk about systems of inequalities. So on Wednesday, we'll get a little bit more practice solving systems of equations via elimination. And then we will practice a little bit with solving systems of inequalities, which are a bit different than systems of equations. Remember, if you had tech problems and you were unable to take exam 3 or unable to finish exam 3 or whatever, you need to reply to the email I sent to your sfcollege.edu email account. I sent a message to those accounts, all of them, everybody in class. If you had problems, tech issues with the exam, you need to reply to that email. Don't send me another email. Don't send me something from Gmail. Don't send me something on Canvas. Reply to the email I sent you. We need to talk through whatever your tech issues were and make sure that they're resolved. Otherwise, you'll run into the same problems when you try to take the makeup. So reply to that email. Let's get things figured out. And then the makeup exam will be on Wednesday during class time. I'm going to be recording the lecture, so you can watch the lecture at your leisure any other time you like. So don't stress about having to miss the lecture that day. But do make sure you communicate with me ahead of time. Otherwise, I will not send you an unlocked token. Otherwise, we won't be getting those tech issues resolved. And it's important that we do, not just for the sake of the makeup, but also for the final exam, which will be run the same way. Okay? If you have any questions or concerns, I got a second or two to talk here. Anything bugging us? Anything we want to talk about before we leave here today? So Manuel asks, on the take home, can we solve by graphing? Only if the problem says to. So there will be problems where I say solve this system using elimination, and you will have to solve those the way they're specified. But there may be a problem that says solve by graphing, and if you do that by graphing, that's fine. So just make sure you follow the directions. If the problem says solve by substitution, you got to use substitution. If it says solve by elimination, you got to use elimination. But if it says solve however you want, and you want to solve it by graphing, or if it says, graph the system and solve it by graphing, that's fine. But there will be questions that require you to use other methods. So you can't just say, I'm going to solve all of these by graphing. And then Haley asked, couldn't we have plugged -1/9 into y equals -2x? Yes, you could. So once you have one of the values, you can actually backsub. You don't have to backsub into the original equations. You can backsub into any of their equivalent forms. And that might be a little bit quicker, yeah. Any other questions here? Okay, so if you need to take the makeup exam for exam 3, reply to the email I sent to your Santa Fe email accounts. Let me know what problems you had so we can fix them. And then be ready to take the test Wednesday during class time. All right? Okay, so I'm gonna go ahead and end the meeting. I hope you guys have a lovely afternoon. If there's anything you would like to talk to me about, just send me a Canvas message, or I do have an office hour tomorrow that you're more than welcome to come by. All right, take care, guys.